Hello everyone, welcome to my channel. In this video, we are going to discuss about the real number line. This is the number line and we have a 0 in the middle, positive integer on the right, and a negative integer on the left. When we move towards the right of the number line, the number keep increasing. And as we move towards the left, the number keep decreasing. Consider any random number, let's say 2. Now choose any numbers to its right, let's say 5. We can say 5 is greater than 2. Now choose another number, let's say 4. Even 4 is greater than 2. If we choose another number to the left of the 2, let's say 1. We can say 1 is less than 2. Suppose we have negative 3. Negative 3 is also less than 2. Here is a very basic thing to remember. Right means larger, left means smaller. This helps us to understand a simple concept. Every positive integer is greater than any negative integer. It is because all the positive integers are to the right of any negative integer. Number lines are a good way to visualize this numerical set. The number line represents set of all real numbers. Every real number has a corresponding point on the number line. As an example, let's use the number line to illustrate the set A. Set A is a set of all element x such that x is a real number. And we have x is greater than 1, x is less than or equals to 4. In this case, the universal set is a set of all real numbers. Since it is understood that all numbers illustrated by the number line are real, we can omit this from our set definition as set A is a set of all elements of x such that x is greater than 1 and x is less than or equals to 4. So now we are going to illustrate the situation on the number line. Kindly focus on the 1. X is greater than 1. So we place empty circles on 1. Then x is less than and equals to 4. So we place a then circle at 4. Since set A also contains all real numbers between 1 and 4, so we draw a solid line between the two endpoints. This set of numbers form what is called an interval. An interval is a set whose members are a continuous span of numbers on the number line. Finite intervals are bounded by the two endpoints. In this example, the endpoints are 1 and 4. The endpoint of an interval don't necessarily have to be included in the interval. However, since set A contains the number greater than 1 and less than or equals to 4, only one of the endpoints, which is the 4, is included in the interval. Intervals which include either side of the endpoint are called half-closed interval or half-open interval. Intervals which include both endpoints are called closed interval. For example, set A is a set of all elements such that x is greater than or equals to 1 and x is less than or equals to 4. So since both endpoints are included, so we call it closed interval. Another example, set A is a set of all elements of x such that x is greater than 1 and x is less than 4. So refers to the example, the endpoints are not included for both sides. So it is an open interval. It is not necessary to use the set Bueller notation when defining numerical set. Another notation called interval notation is often an easier and more compact way to define the numerical set. So as an example, let's use the interval notation to define a closed interval whose endpoints are 1 and 4. So kindly refers to the first example. By referring to the set notation, we notice that x is greater than 1. So we have to indicate the situation by using the parenthesis because the 1 is not included. Then locate the number 1, followed by comma. Next, x is less than and equals to 4. So we have to write down the 4, and 4 is included, so we have to represent by using the square bracket. So here we have the example for interval notation. Next, refers to the second example, x is greater and equals to 1. So in order to represent the situation, 1 is included, so we use the square bracket. Then we have the number 1, comma, locate the value 4. By referring to the situation, x is less than and equals to 4. So in this case, 4 is included, so we have the square bracket. The third example, we have x is greater than 1. So 1 is not included. Then we have to use the parenthesis, followed by 1, comma, then we have the value 4. X is less than 4, which means that 4 is not included, so we have another parenthesis. So here we have the example for set notation and interval notation. In this part, we are going to discuss about the unbounded interval. There are three types of unbounded interval. If an interval has no upper bound, we say that the interval is right unbounded. In the interval notation, this is indicated by replacing the right endpoint with an infinity symbol. So here we have the example for the interval notation. And for the set notation, the set, we have a set of all elements x such that x is greater and equals to negative 1. Another example, if an interval has no lower bounded, then we state that the interval is a left unbounded. This is indicated by replacing the left endpoint with a negative infinity symbol. This is a set for all x such that x is less than and equals to 1 for the set notation. If we express the situation in a set interval, so it will be parenthesis, negative infinity, and then we have 1, then we close the bracket with square bracket because the number 1 is included. Another types of unbounded interval, if an interval has neither an upper nor a lower bound. Here we have the situation. We said that the interval is unbounded on both ends. So the situation would be parenthesis with a negative infinity, comma, infinity symbol, and then another parenthesis because both n does not include it. The interval therefore include an entire number line. N is equals to the set of the real number. So the set notation, we just write the real number. For your information, in an interval notation, an infinity symbol is always enclosed with the left or the right parenthesis. This is because the infinity symbol does not represent a number, so the number is unknown. It is a symbol which indicates that the interval goes on forever in the positive or the negative direction. Therefore, use the parenthesis to indicate that the infinity symbol is not a member of the set, meaning that the number is not included. So as a conclusion, we already discussed about the bounded situation and also the unbounded situation. So for the bounded situation, we have the example, open parenthesis, which means that not included, where we have A as a representative for the number and B. Then we have the closed parenthesis. This is what we call the open interval. Next, we have another example, which is the half open or half closed interval. So the final example for bounded cases will be the closed interval, where we have square bracket for A and square bracket for B. So this is what we call the closed interval. Next, we move on with the unbounded case. So number one, we have -1 until positive infinity. This one considered as no upper bounded. Another one, we have -infinity until 1. This one is no lower bounded. For the third case is neither an upper nor a lower bound, where we have all real number. As a conclusion, this is the basic for the interval and set notation. So later we will explore this set which contain multiple intervals that involve the operation such as union and intersection between the set. So here we are, and thanks for watching.